Welcome back to another lesson in MCV4U. Today we'll be continuing our understanding on the chain rule. We'll be doing different examples that cover the chain rule that we started to look at previously. So the chain rule, if you recall, if h of x is equal to f of g of x, then h prime of x is equal to f prime g of x times g prime of x. So really, when we looked at it, it was the derivative of the outside times the derivative of the inside. Okay, or if we look at it here, for y is equal to f of u and u is equal to gx, then dy over dx is equal to dy over du times du over dx. Okay, so let's look at this example here. So example one says find the derivative of each of the following functions and do not simplify derivative. Okay, so here we have y is equal to 10x plus 6 over 2 minus 8x cubed times 5x plus 3 squared. And so the first thing you want to look at is if you're able to simplify f of x. So, can you simplify of x? And here we can see that we can take out a few common factors. So here if we rewrite this as y is equal to 2 5x plus 3 over 2 1 minus 4x cubed, and we still have 5x plus 3 squared. So here, 2 will cancel out, and here we'll be left with y is equal to 5x plus 3 cubed over 1 minus 4x cubed. And that's all multiplied by 5x plus 3 squared over 1. And here, if we multiply 2 together, we see that there's 2 5x plus 3 both in the first term and the second term here. So here we have the f5x plus 3 to the power 3 times 5x plus 3 to the power 2. And we can just use our exponent rules here. We multiply exponents with the same base, we can add those. So here we have our expression that's simplified as 5x plus 3 to the power 5 over 1 minus 4x to the power of 3. Okay, so here, that's our simplified expression. So now we want to find y prime of x. And here we see that we are now need to use the quotient rule. And the quotient rule, if you recall, is f prime of g minus f of g prime over g squared. Okay, so now we're combining the idea of quotient rule with the chain rule. So this is quotient rule. Quotient rule, and then the chain rule here as well. First thing we want to do is we want to find f prime. So again, f prime here is equal to the outside. So 5 bracket 5x plus 3 to the power 4, and the inside is 5. And then g, which is simply just 1 minus 4x to the power 3 minus, and now we just write f. F is 5x plus 3 to the power 3, and then g prime of x. So outside again, which is 3, 1 minus 4x to the power of 2, and the inside, which is just negative 4. I mean, let's just rewrite that a little bit so we have some more space. Okay, and that's all over c squared. So that would be, so that's 1 minus, so g squared is 1 minus 4x to the power of 3 squared. So then we're going to multiply those exponents, which will give us 1 minus 4x to the power of 6. Okay, so again, here it says do not simplify the derivative. So that would be our final answer here. Okay, let's look at B here. So it says y is equal to x squared square root x plus 1 over x squared plus 1. So here with the square root, we want to square root, we want to express as something to the power of 1 over 2. So here, if we rewrite the expression, y is equal to x squared times x plus 1 over x squared plus 1 to the power of 1 half. And here, we're going to use, again, product rule. So here, we'll label this as f of x, and this entire expression here as g of x. Again, recall product rule. Y prime is equal to f is equal to f prime of g, f prime of g plus f g prime. Okay, so here we get y is equal to, first thing, we'll do f prime, f prime. So derivative of x squared, which is just 2x. And then we want to find the derivative of, or just, no, sorry, just the value of g. So we'll rewrite that. G of x is just x plus 1 over x squared plus 1 to the power of 1 over 2. And then plus f, which is just x squared. And then now we finally have to find g of x, or g prime of x. So g prime of x is going to be the outside. So we move the outside here. So we have 1 over 2 x plus 1 over x squared plus 1 to the power of 1 over 2 minus 1, so n minus 1, which is negative 1 over 2. So this is the outside of g. And now the inside of g. Okay, so the inside of g, we're going to have to use the quotient rule. So we'll multiply that. So here, if we use quotient rule, we get 1 times x squared plus 1. So f prime of x times g of x minus f of x times g prime of x over g squared x, which is x squared plus 1 squared. Okay, and so this would be the inside of g of x here. Okay, and again, we're not simplifying these expressions here, so we'll keep that as our final answer. Okay, so let's continue on. If you look at this, it says factor f of x is equal to 2x to the power of -1 minus x squared. So, so how do we factor this? So again, we always factor the x with the lowest exponent. So here, so factor x with the lowest exponent. And in this case, the lowest exponent would be -1. So here, if we factor out a -1, or x -1, so f of x is equal to x -1. So we're left with 2 minus, and so what are we left with when we factor out x to the power -1 from x to the power of 2? So if we look at that, x to the power of 2 divided by x to the power of -1, that gives us x to the power of 2 minus -1 is x to the power of 2 plus 1, which is equal to x to the power of 3. So we factor out x to the power of -1 from x to the power of 2. It leaves us with x to the power of 3. Okay? And here we can just check to make sure our answer is correct. So if we multiply the x to the power of -1 back in, then we get f of x is equal to 2x to the power of -1 minus x to the power of -1 times x to the power of 3, which is equal to 2x to the -1 minus x squared. So we see that we have completed the check and the way that we factored it was correct. Okay, so let's take a look at this. So it says differentiate and simplify. So again, differentiate again just means to find the derivative. So here we have f of x is equal to 5 square root 3 minus 2x bracket x squared minus 4 to the power of 4. And here we want to rewrite, again, the square root as whatever is inside to the power of 1 over 2. And so let's take a look at this. Let's rewrite this. So we have f of x is equal to 5 3 minus 2x to the power of 1 over 2 and x squared minus 4 to the power of 4. So here, if we label this, we can see that we can label this first term as g of x and the second term h of x. So here we're going to be using the product rule again. So here we have f prime of x is equal to g prime h plus g h prime. Okay, so here f prime of x is equal, so we'll start with g prime of x. So again, move the exponent to the bottom. So 5 times 1 over 2 times 3 minus 2x to the power of 1 over 2 minus 1. So -1 over 2. And that would be the outside of g. And the inside of g would simply just be -2. And then h of x we have here as x squared minus 4 to the power 4 plus z, which we can write as 5 3 minus 2x to the power of 1 over 2, and then h prime of x. So again, outside, bring the 4 down, which is 4, x squared minus 4 to the power of 3, and the inside, which is 2x. So we just write it as 2x. Okay, so this again is outside h, outside h, and inside h. And this one is inside G. Okay, so here, if we simplify some of our expression and see what things we can put together. So here, 1 over 2 and negative 2, that'll simplify to 1. So here, if we rewrite our expression, we have f prime of x is equal to 5, so negative 5, 3 minus 2x to the power of negative 1 over 2. And then we still have squared minus 4 to power 4. And here, if we look at our coefficients, we have 5, 4, and 2. So 5 times 4 will give you 20, 20 times 2 will give you 40, and there's the x there as well. So plus 40x, 3 minus 2x to the power of 1 over 2, and x squared minus 4 to the power of 3. So here, when common factoring, like we did in the lines on question, we pull out the lowest exponent factor. If we look here, we have a couple of things we can take out as a common factor. Here we have negative 5. We have 3 minus 2x to the power negative 1 over 2. And here we can take out x squared minus 4 to the power of 3 as our lowest. Okay, so we'll take those out, and we'll be left here with negative 5, 3 minus 2x to the power of negative 1 over 2 times x squared minus 4 to the power of 3. What we have left over is we have x squared minus 4 to the power. Now it's from the power of 3, we power 4, we took out x to the power of 3, so we just have 1 left here, minus 40x divided by negative 5, just negative 8x, and we have 3 minus 2x. We took out 3 minus 2x to the power of negative 1 half, and if you take that out, so if you think about negative 1 over 2, 1 over 2 divided by negative 1 over 2, that equals to 1 over 2 plus 1 over 2, which is equal to 1. So now we're left with negative 8x, and then just 1, 3 minus 2x. Here, if we expand whatever is in the brackets, so we have negative 5, 3 minus 2x to the power of negative 1 over 2, x squared minus 4 to the power of 3, and inside the brackets we have x squared minus 4 minus 24x plus 16x squared. So here we can, this is a difference of squares. So let's expand that. So here with -5, 3 minus 2x to the power of -1 over 2, x plus 2, x minus 2 to the power of 3. Here, if we combine our like terms, we're left with 17 the 17x squared minus 24x minus 4. Okay, we're going to distribute this exponent into x plus 2 and x minus 2 with the power of 3. So here, we can rewrite our expression as -5 x minus 2 to the power of 3, x plus 2 to the power of 3, 17x squared minus 24x minus 4. And on the bottom, with the negative exponent of 3 minus 2x to the power of 1 over 2, you can rewrite it as 3 minus 2x to the power of 1 over 2. And we can change that back into that square root. So our final answer here equal to -5 x minus 2 to the power of 3, x plus 2 to the power of 3, 17x squared minus 24x minus 4, all over the square root of 3 minus 2x. Okay, let's finally look at this last example here. And this last example says, given that y is equal to 3u over 1 minus 2u minus u cubed, and u is equal to square root 2x minus 1. And so that's going to be inside the function. Determine the value of dy over dx at x is equal to 5. Okay, so here, just a quick note before we start this question. So note, this is a composite function given u in terms of an intermediate variable u. And so here before we might have thought about subbing u into the equation, but we don't want to do this in these types of questions. Instead, recall Leibniz definition of the chain rule, which is dy over dx is equal to dy over du times du over dx. So let's take a look at this. So let's write this out. So we have dy over dx is equal to dy over du times du over dx. And we'll split this up into 3 parts. So dy over dx, we'll put as number 3, dy over du as number 1, and du over dx we'll put as number 2. Okay, so let's start with number 1, which is dy over du, or just y prime. Okay, so let's find y prime. So dy over du is equal to, and if we look at our original expression, so here we're using the quotient rule. So we have 3, so the derivative of that numerator, then the denominator is 1 minus 2u. Okay, and here we have minus 3u times the derivative at the bottom, which is -2, over 1 minus 2u, and that's squared. And here we also have our negative 3u squared, which comes from the negative 3u squared on the outside. So quotient rule. So quotient rule for here. And just simple derivative for the negative u to the power 3. Okay. And here, if we know that u is equal, so here if we know that u is equal to square root 2x minus 1, if we sub in x is equal to 5, so u at 5 is equal to square root 2 times 5 minus 1, you see that's going to be square root 9, which is equal to 3. So the next step, we're going to sub in the value of u is equal to 3 into the equation. So here we have dy over du at u is equal to 3. We're going to sub in that value of u is equal to 3, which we just found there as well. So here is equal to 3 bracket 1 minus 2 times 3 minus 3 times -2 over 1 minus 2 times 3 squared minus 3 times 3 squared. Okay. So now we can simplify this. That'll be equal to -15 plus 18 over 25 minus 27. So this will be 3 over 25 minus 27. And over common denominator of 25, we'll get 3 minus 27 times 25. So it'll be negative 672 over 25. Okay, so we found the first thing for dy over du, or y prime. So here for the second, we're going to find du over dx equal to du over dx. Since we can rewrite of the square root 2x minus 1. So here we rewrite it as 1 over 2 square root 2x minus 1 times 2. So here, again, we found the derivative of du over dx from the function u is equal to square root 2x minus 1. So we get 1 over 2 square root 2x minus 1, and then multiplied by the derivative of the inside, which is 2. The 2's will cancel out. So here we'll have 1 over square root 2x minus 1. And so we'll find du over dx here at x is equal to 5 is equal to 1 over square root 2 times 5 minus 1, which is equal to 1 over 3. Okay, and the third here, is to find dy over dx, which is equal to dy over du, which we've already found, and du over dx, which we just found as well. So that's equal to negative 672 over 25 times 1 over 3, and therefore our final answer for dy over dx is equal to negative 224 over 25.